So today we will be discussing solutions. Okay, so in the solutions, first thing you need to focus here is, okay, so in this chapter, first thing you need to focus is concentration terms. What you need to focus? Concentration terms. Concentration terms. Okay, and the next, solubility. What I am saying? Solubility. Okay, and factors affecting the solubility. What are the factors? Okay, so the next thing is, see, what do we mean by solubility? Like in solutions, we know there is something called solute and solvent. Now, what are the factors that are affecting on the solubility of a solute in the solution? Okay, I will tell you about that. The next thing is properties of solutions. What is the next thing? Properties of solution. These are the things we need to focus here. Okay, so first thing here, concentration terms. Definitely one question in your final exam. Okay, and we have studied this in the mole concept also. Okay, and the next thing is here, from the properties of solutions, you know, there is a special property like considered as colligative properties. Colligative properties. From here also one question. So these two questions are for sure in the final exam. Okay, and in between, yeah, we can expect we'll cover all those things. Okay, let's quickly discuss about concentration terms first. Okay, yeah, so tell me, like what do we mean by concentration terms? Before coming to this, see, in order to make a solution, we have two terms. One is solute and other one is solvent. Okay, so we are mixing solute in the solvent to make this solution. Okay, so now here, how can you identify solute and solvent in a given solution? For example, I am making a sugar solution. What I am making? Sugar solution. For this purpose, what are the two things we required? Sugar and water. So now which is solvent, which is solute? Here it is. See, now remember, here it is easy. Why? Because like we are making this sugar into it, like that you are saying. See, you just remember one thing first. First you check it, look at this physical state. What I am saying? Physical state. What is the physical state of this solution, sugar solution? Liquid, right now. So which is liquid out of these two? Water is liquid now. So it means the one which is having same physical state as our solution is considered to be solvent. This is the first factor you need to know. Always don't say that one which is major quantity, that is solvent. Don't consider like that. First factor is what? Physical state. The one which is having same physical state as our solution, that is considered as solvent. Is this clear up to here, everyone? Okay. So now here, look at this. I am making sugar syrup. Sugar syrup. So syrup. Okay. So sugar syrup, how it will be? In the liquid state only. Okay. Here, in order to make sugar syrup, I want a sugar. For, let us say, for making 100 ml or 100 grams. So I will be taking 60% of sugar, 40% of water, in order to make that 100% sugar solution, sugar syrup. So now tell me, which is solute, which is solvent here? So now what I told you, no matter how much quantity it is, what we need to look? Physical state. So sugar syrup, what is the state of it? Liquid. So which is liquid here? Water. Don't look at the quantities always, look at the physical state. Okay, is this clear, everyone? Okay, one more example I am giving you. You know, copper sulfate in water. H2. So I hope you know this copper sulfate is a salt. What is the physical state? And what about water? And this one, CuSO4.5H, blue vitriol will say. What is its physical state? It is also solid form, blue color thing, blue vitriol will say. Okay, this is also solid. So now identify which is solute, solvent in the given mixture. Once again, CuSO4 is Why solvent? Because same physical state, same physical state. This one is our solvent here. Everyone clear with this? Okay, next. Okay. So now, what is the basic definition of solution? Solution means it's a homogeneous mixture. What I am saying? Homogeneous mixture. Homogeneous means what? It should contain uniform phase, uniform throughout the solution. Okay, it means it's a single phase system. What I am saying? Single phase. Single phase means physical state will be looks only one like that. Okay, so for example, sand plus water if you add, don't say it as a sand solution. Why? Because it has two different phases, water separated, sand separated. They won't mix now, so it cannot be considered as a homogeneous mixture. It is a heterogeneous. Okay, we are saying solutions for which one? Only for homogeneous mixture. Now, types of solutions. So solutions can be in the gaseous phase, in the liquid state, or in the solid phase also. Don't say solutions means only liquid. No. For example, here I am saying air, like this air, whatever atmospheric air is there, that is also considered to be one solution. Why? Because it is a mixture of, it's a homogeneous mixture of different gases. Na? Is it homogeneous or heterogeneous? So it's a homogeneous mixture of different gases means I can say it as a solution. Next one, liquid phase. Liquid solution means that is what? Salt solution, sugar solution, all these things comes here. Solid solutions means what? Like alloys, like brass, bronze, like that we'll say na. So now what they will do? They will mix two metals. When they mix two metals, it will looks like homogeneous mixture. See, for making your ornaments, what they will do? They will add some amount of copper to the gold, right now. Is it looking separate or is it looking homogeneously? Homogeneous. So it can be also considered as a solution. Solid solution. Is this clear, everyone? Okay. Next. So now, in order to express the concentrations of the solutions, we have concentration terms. Again, what I am saying, in order to express the concentrations, like what is the quantity of solute present in the solution, to express that. For example, I am making a salt solution by mixing 5 grams of salt in 100 ml of water. Okay? Or I am making one more salt solution by mixing 10 grams of salt in 100 ml of water. Do they have same quantity? No. So they have different quantities now. So in order to express how much quantity of solute is present, that is what we say concentration. Okay, so to express amount of solute or strength of that solution, we are using something called concentration terms. Okay, so the first concentration term is strength of a solution. What I am saying? Strength of a solution. So strength of a solution means amount of solute in grams dissolved in 1 liter of solution. What I am saying? 1 liter of solution. See, weight of solute dissolved in 1 liter, like volume of solution. So weight should be in grams, volume should be in liter. So this ratio is called what? Strength of solution. So what are the units for strength of solution now? Gram per liter. What is that? Gram per liter. So write this. Once again, tell me, what do we mean by strength of solution? Everyone clear with this? Okay. So now, next thing. Weight by weight percentage. Do you remember this concept? Weight by weight, volume by weight, volume. We discussed at the initial cases. Tell me, you just give me the definition for this or formula for this. Weight of a solute present in total weight of solution into 100. Like this we did. Okay, percentage, no, that's why 100 you are taking. And one more thing. For example, I am saying 30% weight by weight NaOH. What does it mean? Tell me fast. See, weight of solute present in total weight of solution. So 30 grams of NaOH present in 100 grams of solution. It means what is the weight of solute, what is the weight of solvent? Tell me. 30 grams is a weight of solute. 30 grams is the weight of NaOH. Okay. Now 100 grams of solution I am saying now. Solution is nothing but weight of solute plus weight of solvent. Okay. Equals to 100 grams. Now what is the weight of solvent if I ask? So weight of solvent will be 100 minus 30. So 70 grams. Is this clear everyone? We already discussed all this thing in the beginning of the sessions. Okay. Right. Now one more term you tell me. What about molarity? Number of moles of solute by volume of solution in liters, right now? Okay. So now number of see from now onwards let us say solute indicate with B. What is this? Solute indicated with B. Solvent let us indicate with A. Okay, for our simply like writing purpose only. Okay. Now what I can write, number of moles equals molarity equals to number of moles of solute. Now I am indicating with NB. NB means number of moles of solute, total volume of solution in liters. Then how can I modify these? Number of moles means what I can write, weight of a solute, weight of that solute by molar mass of that solute. Number of moles means what is the formula ma? Given weight by molar mass, now that is what I am writing, into 1 by V. 1 by V. V should be in liters. Okay. So if I am expressing in ml, here you should write 1000. Is this clear? Okay. The next thing is, what is this V means? Volume of solution here. Okay. So now what I am doing is, this one weight of solute by volume of solution into 1000 by molar mass of solute. Like this we are writing now. See, weight by volume. Okay. So you can see here weight by volume into 100 into 1000 means 100 into 10 I can write by MB, molar mass of solute. So now what is this weight by volume? Percentage, like what it is, like weight by volume into 1000, 100. It means what I can write? See, weight by weight percentage, here weight by volume percentage. So I can simply write molarity equals to weight by volume percentage into 10 by molar mass of B. These formulas you have written once, check, is that there? Yeah. Next thing is, now the same formula I wanted to connect it with the strength of solution. What is the formula of strength of solution? Tell me. Strength of solution. How you have written this strength of solution? Weight of solute by volume of solution in liters. Right now? Okay. Weight of solute by volume of solution in liters. So if you observe this formula, molarity equals to number of moles of solute by volume of solution in liters we have written. So number of moles of solute I can write as weight of solute by volume of solution in liters into number of moles. Now what I can write? Weight of solute by molar mass solute. See, weight by volume means what is that? Weight by volume in liters. So molarity equals to strength of solution divided by molar mass of solute. So this is an important relation. We have a question in EAPCET. Okay. So what they are asking, molarity equals to strength of solution by molar mass of solute. For example, I am giving you molarity is equals to 0.1 molar H2SO4 solution. H2SO4 solution. Then its strength. It means gram per liter. Tell me what is its strength? What I have given? Molarity I have given. I am asking you strength. So how do you do that? Fast. So molarity is given now. How much molarity is given? 0.1. What I am asking? Strength of solution. This one, what is the molar mass of sulfuric acid? 98. So strength of solution will be 0.1 into 98. So strength of solution equals to molarity into molar mass of that solute. So 9.8 gram per liter. So it means, what does it mean? In order to make 0.1 molar sulfuric acid solution, what I am saying, in order to make the 0.1 molar sulfuric acid solution, how much quantity of sulfuric acid you need to dissolve in 1 liter? ఇలా 0.1 molar solution sulfuric acid solution రావడానికంట we need to dissolve 9.8 grams of sulfuric acid in 1 liter solution. 1 liter solutionలో మీరు 9.8 grams sulfuric యాసిడ్ని డిజాల్వ్ చేసినామనుకో మనకి ఏమొస్తుందట మొలారిటీ 0.1 మోలార్ సొల్యూషన్ వస్తుందంట. అర్థమైందా కాలేదా? ఓకే, నెక్స్ట్ రైట్ వన్ క్వశ్చన్ ఎవ్రీవన్. molarity of 9.8 weight by weight percentage sulfuric acid solution is dash given. So do this. Anyone? See what I am give. What is the data provided? Weight by weight percentage. What is the relation between weight by weight percentage, density and molarity? That's it. So molarity equals to weight by weight percentage into density into 10 by molar mass of that solute. This is the formula. So now tell me, 9.8 into 1.02 into 10 by molar mass, how much? 98. See, 9.8 into 10, 98. 98 removed. So molarity will be equals to 1.02. Clear everyone? Okay. Next. What about molality? Number of moles of solute by weight of solvent in kgs. Okay, then next you can write this as number of moles by weight of solvent in grams. If you write here, it is in kg. Here you can write into 1000. Okay, now I told you about the temperature dependent, independent. Do you remember that? So when you say temperature dependent or independent, if volume term is involved, then you can say temperature dependent. Volume term is involved in the formula, then that can be considered to be temperature dependent. Now tell me about molarity. Temperature dependent or independent? Temperature dependent or molarity, capital M. N by V we are writing now. See, volume term is involved now. So what I can say? Temperature dependent. If there is no volume term in the formula, independent. See, now molality, what you are writing? Number of moles by weight. Do we have any volume term? No. So I can say molality, small m, is temperature independent. Is this clear or not? ఫార్ములాలో వాల్యూమ్ టర్మ్ కనిపిస్తే ఏమనాలి దాన్ని? టెంపరేచర్ డిపెండెంట్. ఇఫ్ నో వాల్యూమ్ టర్మ్, independent. Okay, that's it. Next, what about mole fraction, ma? Mole fraction. Mole fraction is indicated with symbol chi or x is equals to, for example, solute is made up of A and B, then mole fraction of A, if I ask, number of moles of A by total number of moles, Na plus Nb. Similarly, if I ask for B, Nb by Na plus Nb. So if I ask N total, so total, this is chi A plus xa plus xb equals to, like you add these two things, what happens? Denominator Na plus Nb, numerator also Na plus Nb. So both cancel out, it will be equals to 1. So sum of mole fractions of a solution will be equals to 1. So from here, mole fraction of B I can write it as 1 minus mole fraction of A. Like this we can make our mole fraction of A equals to 1 minus mole fraction of B. Okay, remember this. Next. Okay, now what is the formula of molality, ma? Number of moles of solute by weight of solvent in kg. Like this we have written. If I want to write in grams, what I can make? Number of moles by weight of solvent in grams multiplied with 1000. So now what I wanted to do is, I want to relate molality and mole fraction. What I want to relate? Molality and mole fraction. So how can we relate this molality and mole fraction? Just see here, number of moles is fine. Mole fraction formula entama? Numerator number of moles, denominator also number of moles, right now? So now what I want to convert now, this I should convert into number of moles, because both should be number of moles only. But numerator it is fine, but what about denominator? It is only weight is there. If I divide weight by molar mass, it also becomes so weight with what term I am dividing here? Molar mass. See, I am multiplying with molar mass of A and dividing with molar mass. Do you have any issue with this? Okay. So now what I can make here? Nb into 1000 is there, as it is you write. This is Nb. This one what I can write? Na into Ma here into 1000. So is this clear up to here? Okay. So now I am multiplying with N total and dividing with N total. Do you have any issues? Any problem is there? N total means what? Total number of moles, like Na plus Nb. In the denominator also Na plus Nb. If you cancel అయిపోతాయి కదా. So like that I am writing. So just check here, M is equals to Nb by N total. Number of moles of solute by total number of moles. Mole fraction of B, Na by N total. Mole fraction of A into 1000 by Me. So what is the final relation we got between molality and mole fractions? This is a final relation you should remember now. Mole fraction of solute by mole fraction of solvent into 1000 by molar mass of solvent. So in the denominator, solvents only. What are the denominator terms? Once again formula, total formula. Mole fraction of A by mole fraction of B, mole fraction of solute by mole fraction of solvent into 1000 by molar mass of solvent. Write this formula. ఇదా, ఇది ఏంటిది? ఎలా రాయాలి ఇప్పుడు నేను? NB by Na plus NB, ఇదే కదా మోల్ ఫ్రాక్షన్ అంటే. సో వేరెవర్ ఐ హ్యావ్ NB, see NB by Na plus NB. సో దీని ప్లేస్లో నేను కై బి అని XB అని రాయొచ్చా, మోల్ ఫ్రాక్షన్ ఆఫ్ B అని అదే చేసిన. సో నెక్స్ట్ యూ కెన్ చెక్ హియర్ ఆల్సో Na by Na plus Chi A. Okay, clear? Okay, next. Okay, done up to here, everyone? Question. See, write a question, everyone. what is the molarity of, what is the molarity of pure water? Pure water. So this is important question ma, even for exam or even if you go for any interview, they will ask this type of questions. So what they are asking? Molarity of pure water. So how can we answer this? See, what do we know? By default, if density of solution, density of water is not mentioned, then how can we consider? Density of water as 1 gram per ml. What is the density of water? 1 gram per ml. So if they mention like this, what you need to take is molarity equals to number of moles by volume in liters, or other ways weight of solute by molar mass of solute into 1000 by volume of solution in ml. You can take it like this, right now? This is the formula. Okay. So now what they are saying, just molarity of pure water they have mentioned. It means solute is water, solvent is also water. Like that you can consider. Okay. So now what I am saying, say consider volume as 1 liter. What I am saying? Volume as 1 liter. Okay. And what about its molar mass? 18 grams. Okay. And then next you can consider weight as 1 gram. What I am saying? Weight as 1 gram. Why I have taken like this? See, weight by volume means what? Weight by volume. Density equals to weight by mass by volume. So density equals to mass by volume. See, mass is how much? 1 gram. How much ml we are saying? 1 ml. Because here 1 ml. Because here I am taking in ml. Volume should be in ml. So what I should take here? 1 ml. Is this clear, everyone? Okay. So if you take it like this, so what are the remaining terms you have? Tell me now. 1000 by 18. So what is the simplified value here? So you will get this as 55.56. How much you will get? 55.56. So what is the molarity of pure water you will get? 55.56. So the same question can be also asked like this. What is the molarity? Molarity of 900 ml of water. Like this they will ask. So can you do it once? What's the question then? 900 grams you take. Anything is fine, but you take 900 grams. This is the question asked previously. What is the question? What is the molarity of 900 grams of water? So if density is not mentioned, what to consider? Do it now first. See why I have taken here and here 1 as 1, both of them? Because density, it means 1 gram, 1 mole, 1 ml. In 1 ml of solution, how many grams it is present? 1 gram is present, like this. Okay. So here also you do in the same way. So what you can say? Weight molarity equals to weight of solute by molar mass of solute into 1000 by volume of solution. Okay. So now what I can do, tell me, what is the weight of solute given? 900. Okay, fine. What about 18 into 1000? Now what about solution volume? 900 only. Why 900? Because density is 1 now. Perfect. So now what is remaining? 1000 by 18. So same answer. So it means if they mention what is the molarity of water itself, pure water, whatever may be the quantity given, by considering density as 1 gram per ml, what will be your answer, final answer for 55.56. Okay, pure water molarity is how much now? Don't say it is 1 molar. Okay, it is 55.56. Next. Right, one more question. Mole fraction of a solute in solution. Okay, so what the question they have made here, one sec. Mole fraction of a solute in 100 molar aqueous solution. So what is the data provided? Molality provided, na? What they are saying, molality 100 molar they are saying, it means it is a molality mentioned. What is the basic line, basic definition of molality, tell me? Number of moles of solute present in 1 kg of solvent. Once again, number of moles of solute present in 1 kg of solvent. Perfect. So number of moles, how many moles? 100 moles present in 1 kg of solvent. What is our solvent here? See, aqueous solution. Water is our solvent. So from these, what I can write? Number of moles of solute, that is B indication, is how many moles? 100 moles. Clear everyone? Next, from this definition only, from this line only, I am getting weight of solvent. That is, what is this weight of solvent? What is our solvent here? Water. How many grams it should be now? 1 kg now, because 100 molar means number of moles of solute present in 1 kg of solvent. 100 moles of solute present in 1 kg of solvent. Clear or not by the definition? Okay. So now what I can write? 1 kg or 1000 grams of water. Can I write it like this? Everyone clear with this? Now what they are asking us? Mole fraction of a solute. So mole fraction of solute means mole fraction of solute indicated with symbol B is equals to NB by Na plus NB. So how many NBs we have? 100. What about Na now? This is grams now. Convert that into number of moles. Na, that is nothing but N water is equals to how much? Given weight. Given weight is how much? 1000 grams. Now 1 kg means by what is its molar mass? 18. So by simplifying, how much we will get? 55 point. Perfect na everyone? Yeah. So the next, what is your answer then? So here 55.56. So how much it will be? 100 by 155.56. Right? Okay. Upon simplifying, see how many times it will be? 155 is bigger number. So 0.0 means 1000 it becomes in the numerator. Okay, 1000 by 155 means, see, 15 5s are 75, like that we are getting. 15 6s are 15 6 are 90, again 5 is there. So it means around 6 times and the next 4 times. So this is a mole fraction. Okay, the next one, so what is the next term I am saying? Solubility. See, what is the next term I am saying? Solubility. So what do we mean by solubility? See, the maximum amount of a solute that can be dissolved in a given solution. What is solubility? The maximum amount of a solute that can be dissolved in a given solution. Now, what are the factors affecting the solubility? What I am saying? Factors affecting solubility. First factor is nature of solute and solvent. What is the first factor? Solute and solvent. The second factor is temperature. Third factor is pressure. What are the factors we have? Tell me. Nature of solute and solvent. Pressure. Okay. First thing is nature of solute and solvent. See, we know like dissolves like, that statement, you know that? Like polar compounds dissolve in polar, non-polar in non-polar. Okay. So just write a small statement. If solute and solvent are of same nature, that is like dissolves like. Example, see, sugar if you add in water it can dissolve, but if you add in benzene or something like that, it won't be. Or like salt, you can take, salt is a polar compound that can be dissolved in the polar solvents like water, but not in the non-polar solvents like benzene, toluene or CCl4 like that. Okay, example, salt NaCl in water and but not in non-polar solvents like benzene or toluene or CCl4 solvents. Okay, and what about non-polar solvents? Non-polar solutes also dissolves in non-polar solvents only. Okay, like benzene in toluene, but not benzene in water. Like if you add oil, like whatever the oil you are using for cooking purpose, will it dissolve in water? No. So because it's a non-polar one, so it won't be. Clear up to here? First thing is like dissolves, like nature of solute and solvent. Next one is temperature. So this temperature and pressure are very important factors to understand. Just look at here. I'm saying about temperature. See, during some, when I dissolve something, like when I dissolve some solutes in solvent, what happens? It releases heat. What it will do? It releases heat. For example, మీరు సున్నం వేస్తాం తెలుసు కదా, calcium carbonate. When you add in water, when you touch it, you will feel hot. Okay, so that is an exothermic process. What process? Exothermic. It means low temperature favors more dissolution or more solubility. Okay, like that. Okay, so for a exothermic process low temperature favors. Okay, example, and similarly for an endothermic process and for an endothermic process, high temperature favors. See, for a better understanding, I will give you one more example. You know, I think you have studied one line like this. Aquatic life can best survives in colder regions when you compare with the hotter regions. Have you studied about this anywhere? Okay. So what I am saying, aquatic life can have a better surviving capacity in the colder region when compared with the hotter. Why? Because in the colder regions, the oxygen levels in the water will be more, because oxygen can be dissolved more in colder region. Okay. So if more amount of oxygen in water, so fish, aquatic life can easily take the oxygen from the water, like that they can survive. But when it is in the hot summer areas, they will struggle to take the oxygen from the water, because in summer areas what happens, the water become warm. So the amount of oxygen dissolved will be less. Is this clear? Okay. So that process I can say which type of process is exothermic or endothermic. Colder region na, so exothermic. So for exothermic, low temperature favors. Okay. So some process will be there, endothermic. While you are making tea, what we'll do? We'll take water first and we'll add sugar. Okay, it won't dissolve directly. We'll heat it. Now the dissolution process is more when you are heating. So it means dissolution of dissolving of sugar into the water is an endothermic process. Which process it is? Endothermic process. Now what we are doing? We are supplying heat now. So if you supply the heat, the dissolution is more. It means what is the type of process? Endothermic. So for endothermic process, what type of situation favors? High temperature. So for an endothermic process, high temperature favors. Clear up to here? Effect of temperature, clear or not? So for this, what is the best example I told you? Aquatic life. Second example for this endothermic process, making tea, like dissolving sugar in the water while making tea. Okay, done with this. Next factor is what? Pressure. So now pressure factor, there is no effect of pressure in case of solids and gases, solids and liquids. Why solids and liquids? Because solids and liquids are incompressible. They won't compress now. So even if you apply high amount of pressure also, there is no change in the volume of this particular solid substance or even liquids also. That's why no effect in case of what? Solids and liquids. But it will show effect on gases. So solubility of gases can be affected by what? Temperature as well as pressure. Okay, remember. So now the best example here is, this is summer and most of you like to take soft drinks like thumbs up, Sprite, something like cool drinks. Okay. So now what is that? Like those cool drinks are nothing but carbonated water only now. So now what is mean by carbonated water? See, if this is a container having water, what it contains? Water. So now what they will do is, they will supply some CO2 gas, that soda gas you are seeing now. So what they will do? So they will pump this CO2 gas inside the water. Okay, they will use high pressure now. So now what happened? Some amount of this CO2 gas will dissolve into the water, and when you take it, you feel like something like what kind of sense? So what is it? So some amount of CO2 will be goes and dissolves into the water. So now the solubility of a gas, what I am saying, solubility of a gas in water is directly proportional to the pressure of that gas applied. What I am saying, solubility of a gas directly proportional to the pressure of that gas on the surface of the liquid. See, here liquid is there now. So now what I am doing, I am applying high pressure on this gas. Now what that gas will do? It will dissolve more amount into the water. Yes or no? So how much amount of this gas solubilized depends on what? The pressure that you are supplying to this gas while dissolved. Yes or no? Is this clear, everyone? Okay. So this thing is called Henry's law. What is that? Henry's law. So Henry's law. Now what we are discussing? Henry's law. So what is the use of Henry's law? Once tell me. It explains the effect of pressure on solubility of a gas in liquids. Once again, effect of pressure on solubility of gas in liquids. Okay, you should say in that simple line, Henry's law. So now what I am saying is P gas, partial pressure of a gas directly proportional to solubility. So solubility is nothing but, once again, definition of solubility, they write the definition you have written once. Solute dissolved in solution. Solute dissolved in solution. That is nothing but concentration only now. So now what are the concentration terms we have discussed? Molarity, normality, like this, mole fraction. So in Henry's law, by default we are considering what? Mole fraction. Mole fraction of that gas. Mole fraction of that gas is nothing but what I am saying, it is solubility. Now solubility is expressed in terms of what? Mole fraction. What is that? Mole fraction. So I can write here P gas. I am removing this proportionality and writing KH, X gas. What is this KH? Henry's constant. Okay, so all this story will be applicable at a particular temperature, It means during this Henry's law, during this effect of pressure, what we kept constant here? Temperature should be kept constant. Okay, clear up to here everyone? Ardhamainda kaleda? So what is the final formula for Henry's law, tell me? Pressure of a gas is equals to Henry's constant into, okay, P gas equals to KH X gas, like that you can remember. Okay, next thing is what I told you, that aquatic life, oxygen, what I told you, at lower temperature more amount of gas is present in the water, I told you, dissolved oxygen is more. So if you increase the temperature of water, the dissolved oxygen comes out now. So it means upon increasing the temperature, solubility of a gas decreases. Is this clear? Upon increasing temperature, what happens to the solubility of gas? Decreases. Okay, so it means high temperature, low solubility. Okay, right. So now this KH, value of KH is there now. KH is directly proportional to T. If you increase the temperature, what happens to KH also? If you increase the temperature, what happens to KH also? Increases. So high temperatures, low solubility. High temperature, high KH and low solubility. So it means if value of KH is high, then solubility will be low. Can we say like this? Everyone clear with this what I am writing? High temperature, high KH, low solubility. So simply I can say if value of KH is high, then solubility of that gas is low. So it means I have two gases, gas 1, gas 2. Its KH value is, KH is equals to 50, let us say. And for this, okay, KH, ATM. For this, KH equals to some 100 ATMs. So tell me, which gas has more solubility? G1 or G2? Gas 1 or gas 2? So what I told you, higher KH, lower solubility. So from these, I can say KH inversely proportional to solubility. So G1 is greater than G2. For what? Clear or not this concept? Okay, we have some NEET questions on this directly, ma. Very simple one. Okay, nothing to calculate, just observe the data provided, that's it. Okay, they provided like gas 1, gas 2, gas 3 with the 3 KH values. Now what to check? Higher KH? That's it. Okay, next. See, what are the units for mole fraction? No units now, number of moles in numerator, number of moles in denominator means no units. So it means P gas you are writing as KH X gas. See, this fellow has no units. It means whatever the units for partial pressure, same units will be there for kH. Clear now? Yeah. So the next one, if I want to draw a graph, how can I draw this? Partial pressure of a gas and the solubility of a gas here. So y equals to mx type of graph we'll get. Y equals to mx. So we'll get a straight line like this. So slope is kh. Next. Done up to here. So the question here in the exam, I will give you the question. First you write up to here. Done with this? Write the formulas only and these single line statements fast. Okay. Write the question, everyone. Question up to here done now, everyone. So write a question, everyone. CO2 gas is bubbled through water during a soft drink manufacturing process. Says at 298 Kelvin. If CO2 exerts a partial pressure of 0.835 bar, then X millimole of CO2 would dissolves in 0.9 liter of water. The value of X is given KH is equals to 1.67 over 3 bar at 298 Kelvin. Okay. Okay, so tell me, so what they are saying, once check. See, CO2 gas is bubble through CO2 gas is bubble through the water during a soft drink manufacturing process. Okay, if CO2 exerts a partial pressure of this much, PCO2 is how much? 0.835 bar. Just listen this question, very simple, you can easily do. The next, X millimole of that CO2 would dissolve. See, by applying this much pressure, some amount of CO2 will definitely dissolve, no? So how much amount they are saying? X millimole they are saying. Okay, it means how many moles of CO2 dissolved we need to calculate. Okay, would dissolve. How much quantity of water they provided? So water provided is 0.9 liters, or I can simply write it as 900 ml of H2O I can write. Yes or no? So water density is 1 now. So instead of saying 900 ml, I can also write it as 900 grams also. Do you have any issue with this? Do you have any issue with this? No. Then next one, the value of X, how many millimoles of CO2 is dissolved they are asking. See what the data provided again, KH also given. So now what we need to do, P gas is equals to KH X gas. Okay, now I want this one now. So KH X gas equals to P gas by KH. How much it is? P gas is how much? 0.835 bar by 1.67 into 10 power 3 bar. Same units now, bar is removed. Okay, if no units means our mole fraction we are getting. So this is how many times? This is 2 times if you calculate. So 10 power 3 is there now, 2 into 10 power 3. I can write 1 by 2 means what? 0.5 into 10 power minus 3, or I can simply write it as 5 into 10 power minus 4. So what is this value we got? Mole fraction of that CO2 we got. How much it is? 5 into 10 power minus 4. See, mole fraction means what is the formula? Number of moles of CO2 by total number of moles. Total number of moles means N CO2 plus N H2O. See, the question they haven't asked you about mole fraction. They are mentioned it as X millimole. It means they are asking about moles, millimoles. Okay, so it means this value they are asking, this one. Okay, see here 5 into 10 power minus 4 means smaller value or bigger value? Very small value, no? It means denominator might be like this value I am saying. Whenever that smaller value is there, I can simply take this as C. NCO2 I want. NCO2 here also I am writing. NH2O means what I can do? What is the quantity they have mentioned? 900 ml now. Water, how many moles they have, grams provided? So 900 ml or 900 grams I am taking. What is its weight? 18 gram per mole. So how many times it will be? Gram cancel, 90, 18 5s are 50s. Clear everyone up to here? This is clear or not? Yeah. So here I can write 50, which is equals to 5 into 10 power minus 4. So now what I can do? I want this numerator value. So NCO2 equals to, can send this here. What happens? 5 into 10 power minus 4 into NCO2 plus 50. Now look at this. Multiply this inside 5 into 10 power minus 4 NCO2 plus 550 means 250. 250 into 10 power minus 4. See, 5 into 10 power minus 4 is a bigger value or smaller value? Some little bit bigger value plus very smaller value. Can I ignore this number? Yeah. So what is our final answer now? So 25 into 10 power minus 3 moles NCO2. So what is your final answer? 10 power minus 3 means, how can I write? This one. 10 power minus, see 10 power plus 3 means kilo I am writing. 10 power minus 3 means you can write millimoles. So what is your final answer for this question? 25 millimoles. What is our X value here? 25. Clear or not? So what are the steps we followed? Tell me. Question looks big but very simple. What are the data they provided? P gas provided, KH value provided. From this we calculated mole fraction. So after calculating mole fraction, in the question if they directly ask about mole fraction, that is your answer. But they are not asking mole fraction, they are asking number of moles. Simple, number of moles formula means N number of moles of solute by total number of moles. Use that, simplify it. Simplify, you will get something like this. Okay, write a note out of this. Everyone, please. So will you write a question after this? Done everyone? Finish it fast. I will give a question. Okay. Write the question. The number of moles of N2, the number of moles of N2, the number of moles of N2 from air dissolves in, from air dissolves in 10 moles of water. Once again repeat the question everyone. The number of moles of N2 dissolves in 10 moles of water at 298 Kelvin, and 5 atm pressure, given kh equals to 10 power 5 atms, kh equals to, given kh equals to 10 power 5 atm. So how can you do this, tell me? What is the data provided? Same, once write the data provided. N2 gas, see air means what are the constituent gases we have? It can be N2, O2, CO2, all these things are there. So what is the percentage of N2 if I particularly ask? 75%, like that we will say, na? Okay, so from this air in the water how much N2 is dissolved they are asking. See, what is the pressure they have mentioned? 5 atm. Next, kh 10 power 5 atm. Next, number of moles of water provided, no? 10 moles. Next, temperature at particular temperature 298 Kelvin. Okay, right. So now what we need to calculate? What they are asking? Number of moles of N2. So same steps like this. So tell me what you need to take. P of a gas equals to kh x gas. So x gas equals to P gas by kh. So it is a 5 by 10 power 5. 10 power 5 if I write in the numerator it becomes 10 power minus 5. That's it now. So you got mole fraction value. Okay. See, mole fraction values if you observe, very small values you are getting. 5 into 10 power minus 4 here, 5 into 10 power minus 5 means very small values now. It means you can by default you can understand like this. NCO2, like N gas they are saying now, that N2. Okay. So now what I am asking? Mole fraction. Mole fraction means what is the formula? Number of moles of that gas by total number of moles. N total plus N H2. Like this only now. What is the value we got? 5 into 10 power minus 5. See, 5 into 10 power minus 5 is a small value or bigger value? It means definitely the value of N2 will be very smaller value. What I am saying, definitely the value of N2 will be very smaller value. So for simplification purpose I am removing this almost. So that what will get? N2 by H2. Same thing you have did here. You have cancelled out here. So here itself you can do that. So 5 into 10 power minus 5. So the next what you can do? N2 equals to 5 into 10 power minus 5 into NH2O. NH2O how many? 10. So what is the value? 5 into. So how many moles of N2 dissolved? 5 into 10 power minus 4. Everyone clear with this? Okay. So you can solve remaining questions from the book. Definitely you can able to do. Okay. Then next one is okay. See, you are still writing. See, I have liquid A here, liquid B here. So I am mixing them to make a solution. Solution of AB. What I am making? I have liquid A, liquid B. We are mixing them to make a solution. Here you can listen. The process of mixing one liquid into another liquid is called dissolution. What is it? Dissolution. During this dissolution, heat might be released or heat might be absorbed. Once again, during the dissolution process, heat might be released or heat might be absorbed, or there is no change in heat. What are the three conditions I told you? Either heat can be released or absorbed or no change. Okay. If there is no change in heat, you can say it as an ideal solution. What type of solution? During the dissolution process, during this process, if delta H can be greater than 0, it means greater than 0 means, see, what are the conditions I told you? Less than 0 or equals to 0. These are the three conditions I am saying now. Greater than 0, less than 0, equals to 0. If it is equals to 0, you should say that solution as ideal solution. For these two conditions, you should say it as a non-ideal solution. What is that? Once again tell me ma, when we are dissolving two liquids, what happens? Heat may be absorbed, heat may be released, or no change. If no change, you should say. If there is any change, done up to here. Okay. See, now you are going to get three things: ideal and non-ideal solution. Non-ideal solutions are again two types. How many types I am saying? Two types. One is non-ideal solutions which show positive deviation. Which deviation? Which shows negative deviation. Non-ideal solutions are of two types. One, positive deviated solution, negative deviated solution. Okay. So when I am saying positively deviated solution, enthalpy change will be greater than 0. What I am saying? Enthalpy change will be greater than 0. Here negative deviation means enthalpy change will be less than 0. See, look at here, I am mixing liquid A with 20 ml, liquid B also 20 ml. What should be the resultant volume I should get? 20 plus 20 means it should be 40 ml. It means change in volume is 0, I can say. Then that solution becomes ideal. So delta H0, delta V0 means ideal. Now what happens when I am mixing these two of these AB components? Sometimes the change in volume, instead of 40, it can be something like 39, 38, something like that. What is the resultant volume we should get? But observed value, how much we are getting? Less than that now. So less than that means what is happening here? Volume is decreasing now. So negative deviation. Delta V should be less than 0. Okay. Sometimes instead of 40, we may see more than this, like 41, 42. Like that I can say, sir, when it is possible, when it is happens, really in reality will it happens or not? This will be the question now you have. See, A is a component, B is another component. What I am saying, A and B are two components. See, between AA molecules, like it is in a container, this is also in a container. Between AA molecules, the molecular forces are considered to be intermolecular forces. Here also we have intermolecular forces for BB. Yes or no? AA. If the intermolecular forces for AA, BB are almost the same, what is the first condition I am saying? almost same. If I mix these two components, what happens? We'll get a AB type of solution. Since the intermolecular forces are almost same, after mixing also intermolecular forces will be same only. Is there any change? No. Therefore, total change in volume becomes 0. So that kind of solutions are considered to be ideal. So now what is the thing I am saying? If intermolecular forces of AA and intermolecular forces of BB are same, what type of solution we are going to get? Ideal. Is this clear up to here? So okay. Now, what is the next condition I am saying? If intermolecular forces between these two are not same, then definitely there will be change in the volume. Yes or no? Either it will be lesser or it will be greater. Then we will get non-ideal solutions. Okay. See, if intermolecular forces of AA and intermolecular forces of AA and intermolecular forces of BB are greater than intermolecular forces between AB. Once again look at this condition. If the individual intermolecular forces here, before mixing they have more attractive forces, it means how the particles will be very close, but after mixing what happens to the particles? Intermolecular forces are getting decreased. Now what I can say here, are they come closer or they will move forward, far to each other? Far to each other means what type of solution it will be? Non-ideal. Perfect. But positive or negative? Once again ma, look at here. Intermolecular forces before mixing is more. It means particles are very close to each other. But after mixing, their intermolecular forces are getting decreased. Decreasing means will the particles are close to each other or far from each other? Far from each other. Far from each other means volume is expanding or compressing? Expanding means delta V greater than 0 or less than 0? Greater than 0 means positive or negative? Positive. That's it. So you bring this condition and keep it here. Clear everyone? Okay. Now the next condition is what? If intermolecular forces, same thing. What is the thing I need to change? So tell me, before mixing intermolecular forces more or after mixing? After mixing intermolecular forces are more means particles will come closer. If they are coming closer, what happens to the volume? Decreases now. So instead of having our 40 ml, now it will be around 39, 38 like this. So what type of deviation it is? So clear everyone? Okay. Now the question will be like this. See, in the first component, I have some acid or something like acid or anything, let us say chloroform I have. What I have? Chloroform. In second container I have acetone. What I have? Acetone. So what is the structure of chloroform? Cl, 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 H. This acetone means CH3, CH3 with one oxygen, like this now. So before mixing, this is the acetone, this is acetone, this is chloroform. After mixing, what happens between them? What is the intermolecular forces after mixing? What happens, tell me? See, this bond is polar bond or not? So it will become partial positive and oxygen will get a partial negative. What about this one? See, chlorines are this side now. So hydrogen partial positive, carbon partial negative. See, there are the opposite poles. What they will do? They will attract each other. Yes or no? Before mixing, we do not have that kind of attractions. But after mixing, attractions are there. This is nothing but hydrogen bonding now. So whenever there is a hydrogen bonding between the molecules, between the components, molecules come closer to each other. If they are coming closer to each other means what type of forces? Intermolecular forces are more after mixing. So which type of deviation it will show? Negative deviation. Clear or not everyone? So this is an example of negatively deviated solution. Clear everyone? Okay. Now what I am doing, I am mixing CCl4 with water. With what I am mixing? CCl4 with water. See, before mixing if you compare, this is a polar compound, it has hydrogen bonding with itself. This is a non-polar compound. Okay. Now what I am doing is, I am mixing CCl4 with water. What it will do? This is a non-polar, this is a polar. So whether the intermolecular force after mixing is greater or less? Less now. So this solution, resultant solution, what type of deviation? So this is an example of positive deviation. Is this clear everyone? Clear or not? Okay. Now look at this, what I am mixing, you know, benzene like this, and one more we have is toluene. What is that? Toluene. So look at the structures, are they same or different, or how they are? Both of them are non-polar, almost similar groups and everything. So what type of deviation it will show? Once again I told you three conditions. First condition is what? If intermolecular forces between them before mixing, after mixing are almost the same, ideal. If they are not same, two possibilities. Now look at these structures, almost same now. So after mixing, this solution will show what type of deviation? No deviation. No deviation means it is an ideal. అర్థమైందా కాలేదా? ఈ స్ట్రక్చర్ సేమే ఉంది కదా. Benzene, toluene are non-polar compounds. If you mix them before mixing and after mixing, intermolecular forces are almost same. If they same, they form which type of solution? Ideal. Okay. If more intermolecular forces after mixing, negative. Less intermolecular force after mixing, positive. Okay. Now I am taking one simple example, acid and a base. What I am saying? One acid base. See, acid base means definitely they will come closer to each other. So what type of deviation it will show? Acid and base definitely come to each other. దగ్గరికి వస్తుంది అంటే ఏంటమ్మా? Negative deviation, intermolecular forces are more. Okay. Ideal solutions, non-ideal. In non-ideal, two things. Positive deviation, negative deviation. Okay. How can you identify positive deviation? After mixing, if intermolecular forces are lesser, then it is positive. After mixing, if intermolecular forces are more, molecules comes close to each other, so it's a negative deviation. Okay, clear everyone? Okay. So now there is something called Raoult's law. Do you remember? All ideal solutions obeys Raoult's law at all compositions and temperatures. Non-ideal solutions are there now, they won't obey Raoult's law. Okay, I hope you know this. Okay, I think we will complete this. So tell me here, I am adding HNO3 plus NH2. So tell me what is your answer for this? Positive, negative, ideal? Non-ideal. Perfect. Next. See, HNO3 means acid. What about this amine now? Amines are basic. So acid, base. They will come each other, close to each other. So negative deviation. Clear everyone? Okay. So now I will give you one simple understanding thing. You mix anything with CCl4. What I am saying? You mix anything with CCl4. Anything, you will get which type of deviation? Positive deviation. Which type of deviation? Positive. Anything means there are something to understand here. Concept is important. Then this trick. This trick box I am saying. Next, chloroform plus any polar compound. Polar compound. Negative deviation. What I am saying? CCl4. Sorry. Close for chloroform. Chloroform plus any polar compound. What type of deviation? Negative. CCl4 plus anything I am saying? Positive. Okay. See, this is the first thing. This is second thing. It means, look at here what I am making. CCl4 plus chloroform. What type of deviation first you tell me? What I told you, CCl4 plus anything. Follow this order only. Positive deviation. Okay. CCl4 plus water. CCl4 plus benzene. Positive. Next, CCl4 plus acetone. Positive. Do you got what I am saying? Okay. Next thing is CCl4 plus SiCl4. See, carbon, silicon, both belongs to the same group now. I am taking here 4 chlorine, for this also 4 chlorines. It means both of them are almost having same nature now. So this should be what now? Ideal. Ideal. Clear? Okay. Next thing is chloroform plus water. Negative. Chloroform plus CCl4. Chloroform plus CCl4. What I told you, just follow this. If CCl4 is there, that should be first. Chloroform plus CCl4 or CCl4 plus chloroform, anything can be. ఈ రెండిట్లలో ఎవరి పైన ఉన్నారమ్మా? Chloroform. So CCl4 plus chloroform you already written. What you have written? Then chloroform plus CCl4. Clear everyone? Okay. Ethyl chloride plus methyl chloride. Ethanol plus methanol. What is this? Ideal, na? Perfect. Next, this one. Alcohol, alcohol, same size alkyl groups also. Okay. Chlorobenzene, bromobenzene. First, ideal. Okay, all these are important ma. You no need of solving anything, just by looking at the composition, you can easily identify them. Okay, so you can write these examples. Done? Over?